So the powers add up because just imagine an example with, let's say, we want to do 2 to the power of 3 multiplied by 2 to the power of 4.
Mm-hmm.
Okay. Now you know that this is going to be 2 to the power of 3 plus 4, which is 2 to the power of 7. You know that, right?
Yeah.
But why is it like this? Let's think about this. What is 2 to the power of 3? It's a bunch of 2's multiplied together. 2 times 2 times 2, right?
Mm-hmm.
And what's 2 to the power of 4? It's 2 times 2 times 2 times 2. 4 2's
Yeah.
multiplied together. And the whole thing is being multiplied, right?
Yeah.
So if you open this up, what do you get? You get 2 times 2 times 2 times 2 times 2 times 2 times 2. So how many 2's do we have in this multiplication sentence? 1, 2, 3, 4, 5, 6, 7. 3 comes from this side and 4 comes from this side. So this is why we write this as 2 to the power of 7.
Got it.
This is why the powers adding up works in multiplication. But what you're saying is, if we have, let's say, 30x to the power of 2 and plus x to the power of 4.
Okay.
Now, in this case, because there's a plus in between, this one and this one are not multiplied together. So this x squared that we see is x times x, and there's a plus in between that gives us x times x times x times x. That is x to the power of 4.
Mm-hmm.
But the plus doesn't add up the powers like multiplication over here,
Okay.
right?
Yeah. Can I write this down for I could
Yes,
just
please. Yes, sure. Go ahead.
Yeah, this one I want to know how to do this one. I'm a little confused
Okay,
about it.
right.
For this one, when you like, I just have a question. When you do this one, do you multiply all of the top by itself and then same with the bottom and then you try to simplify or no?
Well, I suppose you are expected to apply the laws of exponents over here, not just do normal multiplication and division,
Yeah.
right? But even if you do that way, you're still going to get the same answer. So do you want to give it a shot?
I mean, I just want to do whatever way it's like easiest for I could like
Okay,
remember.
okay. Look, we already, on number one, we already learned a law of exponent, and we also reasoned that out. We understood the reason. Y is x to the power of a multiplied by x to the power of b is equal to x to the power of a plus b, correct?
Hmm.
Now, think about this. A fraction is a division. So if we do x to the power of a over x to the power of b, this is just the opposite of multiplication, right?
Yeah.
If we multiplied two powers, the powers were added, provided they're on the same base, x. This has to be the same. Otherwise, you cannot add them up. But that apart, if multiplication was adding, then what do you think intuitively? Do you have an intuitive answer? If we divide x to the power of a over x to the power of b, what are we supposed to do with the exponents?
Add them? Oh
Hmm?
no. The exponents?
Yes, this is going to be
Um,
x to the power of
it should be A. That's no.
just a. What about b? What do you do with b?
Same thing? No?
No, it's going to be
Add.
subtracted.
Oh,
Why?
subtract.
Because
Yeah.
multiplication, this is multiplication. You agree?
Yeah.
And this is division. You agree?
Yeah.
Yeah. A fraction is always a division.
Okay.
So if multiplication tells us that we should add the powers, then division, which is the opposite of multiplication,
Oh, we should
is
subtract.
subtract.
Okay.
Make sense?
Yeah. So wait, before I write this down, is this all I need to know how to answer that question? Because like I just need to know a way how to answer those questions.
Yes. This is what you need to answer that question. And you're going to combine the powers. You're going to combine, add up all the powers in the numerator and subtract all the powers in the denominator.
So okay, so Okay, I have a question now. So for the numerator, I add everything up into whatever number I get. Is that correct?
The powers,
Yeah,
not the six.
not the six or the three, just the powers.
Just the powers. 4 plus 3 is 7.
4 plus 3 is 7. Okay, wait. So I get that, but so then what? I would have 6x to the 6x to the power of 7 and then times 3. So like would that be it?
Yeah. Like you could do 6 times 3 up front. You
Okay.
could bring all the constants in the front and push the x's towards the back. So you're right. So it's going to be 6 multiplied by 3 multiplied by x to the power of 7 in the numerator, right?
Yeah.
Yeah, over 2 multiplied by, what do you get when you add up all the powers in the denominator? X to the power of minus 2 and x to the power of 1. X means x to the power of 1.
You don't you subtract it?
No, for the denominator, you're still going to add them. So this is going to be x to the power of negative 2 plus 1.
So negative 3 negative 1.
Negative 1, right? So this becomes equal to 6 times 3 over 2. Oops, sorry, over 2, not over 3, over 2 multiplied by x to the power of 7 over x to the power of negative 1. Correct?
Yeah.
Yeah. Now,
Okay.
between these two powers of x, you're going to use this law. You're going to use this. Because there's a 7 and negative 1, these are divided. You are going to subtract them. So this becomes 6 times 3 over 2 times x to the power of 7 minus negative 1. Remember, it's a minus negative 1, not minus 1.
Got it.
The powers are subtracted. Over here, we had an a in the numerator, b in the denominator. We did a minus b. So over this one, in the problem, we have a 7 in the numerator, negative 1 in the denominator. We are doing 7 minus negative 1. So this
Yeah.
turns into what's 6 times 3 over 2, by the way?
6 sorry, 18 over 2?
What's 18 over 2?
9.
Correct. So this is
Oh,
going to
so
be 9
yeah.
times x to the power of 7 minus negative 1 turns the 1 into a positive 1. A negative of a negative makes it a positive. So it's going to be 7
Which would
plus
be
1, which means 9x to the power of
x
8.
to the power 8.
Right.
Got it. Can I write this down?
Yes, please go ahead.
Sorry, it's gonna take a little bit though.